Welcome to Unacademy Neet English. So, guys, quickly let me know in the chats if I'm perfectly audible, visible to each and every single student. Everybody out there, guys. Let me know in the chats if I am perfectly audible, visible to each and every single student. Okay, and smash the like button because liking the session is extremely mandatory. Okay, so liking the session means marking your attendance. Okay, and let the people join. We are starting this beautiful session, and you are going to love this session, that is for sure. Concepts with the problems. Okay, and each and every single concept will be from the scratch. You don't have to worry about anything. Okay, so every single thing will be from the scratch. If you haven't studied these concepts before, okay, doesn't matter. Okay, no need to worry about anything. I'll be starting from the scratch. Let everybody join and smash the like button. Before everything, I would want you guys to smash the like button. Okay, and light up the chats with the fire emojis. Okay, as Wasim sir says, light up the chats with the fire emojis. Huh? This is his quote only. Come on, guys. Everyone means everyone. Session duration is going to be small. It will not be, it'll be around, I would say, 1.5 to 2 hours. That is going to be the maximum duration. And I'll be sharing the PDF also, my dear friends. I'll be sharing the PDF also. And for that, you'll have to join this particular Telegram channel. That is t.me/YAWARMANZOOR. In this Telegram channel, I'll be sharing the PDF and every single detail, every single thing, whatever is mandatory, okay, I share in this Telegram channel. So please do join this Telegram channel, all of the students out there. Okay, this is mandatory. T.me, you can search this in Google and you'll reach onto this particular channel. T.me/Yawar Manzoor, YAWRMANZOR. I think people have joined. We need to start this particular session. I think people have joined. We need to start this particular session. Okay, so let's smash it. Let's smash it, guys. Okay. Now, guys, listen to me very carefully. Whatever the concepts I'll be telling you in this particular session, please take these concepts very seriously. Whatever the problems I show you in this particular session, take these problems very seriously. Okay? Okay? Because questions have been asked many times in the NEET from these concepts. That is the reason I have put up these concepts over here. Extremely important. Sir, will there be only one session? No, there will be more coming in the upcoming days. So be ready for that. Be ready for that also. Okay? Is that clear? Is that clear? I think we need to start now. I think we need to start now. Let's start this particular session. Let's start this particular session. Now, guys, take a look. Take a look. First and the foremost thing, the chapter units and dimensions, okay? It's a small chapter, but it is extremely important. 3 to 4 questions means you can expect from this particular chapter, because every single year, 2, 3 questions have been asked from this chapter. And see. Let's suppose I have got a physical quantity. I have got a physical quantity y is equal to x. Listen very carefully. Y is a physical quantity which depends upon x. Okay. Let's suppose if I change x, we say there will be change in y. If there will be error produced in x, let's suppose x is length. You are measuring the length. You are producing the error in measuring the length. So we say if there is error in x, there will be error in y. Why? Because y depends upon x. Y depends upon x. So if there is change in x, there will be change in y. If there is error in x, there is error in y. Why? Because y depends upon x. We say y depends upon x. Yes. Now, guys, how do we write the error in CCC? If we say y is equal to x, how do we write this error in x? We say it was delta x divided by x. This is how do we write the error, relative error. It will be delta y divided by y. This is how we actually write the error. And my dear friends, if you multiply with 100, so it will get the error in percent. Sir, how many percent error has been produced in y? Okay, So we say multiply with 100 over here, it will give you percentage error. This is called percentage error. Okay. This is called percentage error. Guys, smash the like button. This is called percentage error. Okay, this is called percentage error. Now, guys, I want you to understand one thing. What is that? Listen to me very carefully. Let's suppose y is equal to, we say a raised power n. Y is a physical quantity which depends upon a. What does that mean? If there is error in a, there will be error in y. And how do we write error in a? Guys. How do we calculate error in y? We say it would be delta y divided by y. Change in y upon original value of y. And it will be equals to this power down, n down, delta a divided by a. This is how do we calculate the error in y. If there is error in a, there will be error in y. And if you have to find the error in percentage, multiply with 100 and multiply with 100. So this is called the percentage error in y. This is called percentage error in y. Let's suppose if you have this, guys, take a look. Y is equal to a raised power n, b raised power m. Y is a physical quantity which depends upon a and b. If there is error in a, there will be error in y. If there is error in b, there is error in y. And how do we calculate the error in y? Delta y divided by y multiplied by 100. Okay. This is called the percentage error in y. This will be this power down, take this n down, delta a divided by a. Okay. Then plus, if there is error in this quantity, that will be added to this. Okay. Error of this plus error of this. So that is going to be m down, delta b divided by b. And if you have to find this in percentage, multiply with 100. This is the formula that we use in maximum number of questions to solve. If you have, we say y is equal to a raised power n, b raised power m. If there is error in b, there is error in a. So you can calculate that error. How? N down, delta a by a. Plus m down, delta b by b. Multiply with 100. This is called the percent. Let me show you the question. Guys. Let me show you the question. Take a look at this particular question. See, in an experiment, 4 quantities A, B, C, and D, are measured with the percentage error. 1%, 2%, 3%, 4%. So means A is a physical quantity, B is a physical quantity, C is a physical quantity, D is a physical quantity. So while you were measuring these, while you were performing the experiment, error came in A as 1%. Error came in B as 2%. Error came in C as 3%. Error came in D as 4%. So if there is error in all of these, and you see the relation, guys, take a look at the relation. We say P is equal to, that is A cube, then we say B square divided by CD. So P is a physical quantity which depends upon A, B, C, and D. So if there is error in A, B, C, and D, there will be error in P. And how do we write an error in P? Guys, I can say it is going to be delta P divided by P into 100. This is called the percentage error in P. And it will be, guys, see. 3 down A raised power n. This is 3 down delta A divided by A. Okay. And then plus. We say 2 down delta B divided by B. This is percentage error in A, percentage error in B. Then the C. Sir, it is in the denominator. Yes. Error of this will be also added. So this is going to be delta C divided by C plus error of D will be also added, delta D divided by D. Delta D divided by D. And if you have to find in percentage, multiply with 100. That's it. Now tell me. Guys, this is 3. Delta A by A into 100. Delta A by A into 100. That is given as how much? Delta A by A into 100 is the percentage error in A. That is given as 1%. So I would write over here 1%. Then plus 2 into delta B by B into 100. That is given as 2%. This is 2%. Then we say plus delta C by C. That is given as 3%. Then we say delta D by D. That is given as 4%. Now tell me, this is 3%, 4%. 4 plus 3 is 7. 7 plus 3 is 9. 9 plus 4 is 7 plus 3 is 10. 10 plus 4 is 14. So it is going to be 14%. So error in P is 14%. Is this clear? Please tell me in the chats. Everybody out there. Is this clear? Please tell me in the chats. That's great. That's great. Now, guys, take a look. Let's take a look at this. If this one is simple. If the error in measuring the radius of a sphere is 2%, if the error in measuring the radius of a sphere is 2%, then the error in the measurement of the volume is, see guys, let's suppose this is the sphere. You are measuring the volume of a sphere. You are measuring the radius or volume of a sphere. So while measuring the radius, error came out to be 2%. So what does that mean? Delta R divided by R into 100. So this is called percentage error in radius. This is given as 2%. Okay. You have to find the percentage error in volume. Guys, volume of sphere is 4 by 3 pi r cube. Okay. 4 by 3 pi is constant. Leave constant. So percentage error in volume is delta V by V into 100 is equal to, we say, this, it is CC. We say V is proportional to R cube. Now take this 3 down. 3 down, delta R divided by R into 100. This is percentage error in R. This is percentage error in radius. So you will write 3 into delta R by R into 100. That is given as 2%. That is given as 2%. 3 into 2 will be, that is 6%. So error in the volume is going to be 6%. Okay, let's solve this one. This one is, okay, take a look, take a look. A physical quantity is represented by x is equal to m raised power a, l raised power b, t raised power minus c, t raised power minus c. Okay. If the percentage error, so x depends upon m, l and t. If the percentage error in the measurement of m, l and t are alpha percent, beta percent, gamma percent, then the percentage error in the x will be, guys, how do you find the percentage error in x? Delta x divided by x into 100. It will be power down, a down, delta m divided by m. As simple as that. Then we say plus percentage error in b, l, that is b down, delta l divided by l. Then plus this c down, c delta t divided by t. As simple as that. So we always add the error. We always add the error. We do not subtract the error. Now guys, and multiply with 100, it will give you in percentage. Now guys, can I say this is A? Delta m by m into 100, that is percentage error in m, that is given as alpha percent. So this is alpha. So this is given as alpha. Okay. A into alpha, then plus B into delta L by L into 100, that is given as beta. Percentage error in L, that is given as beta percent. Plus C into delta T by T into 100, that is percentage error in T, that is gamma percent. So I would say this is gamma. So percentage error in X is going to be, that is A alpha, or I would write it like this, alpha A plus beta B plus gamma C. So that is option A. Is this clear? Is this clear? Is this clear, guys? Okay, what about this one? What about this one? If force applied on a square plate of length L, okay, there is a square plate, a force is applied on this, okay, length is L. If the percentage error in the determination of the length is 2% and force is, guys, what is the permissible error in the pressure? We say pressure is force upon area. What is the area of the square plate? That is L square. So pressure is force upon L square. Now delta P divided by P into 100, okay, is equal to, here, that is going to be delta F divided by F. This is percentage error in force, plus percentage error in this, that is 2 delta L divided by L. Multiply with 100. Now this is the final equation. So here delta F by F into 100 is given as 4%. Delta L by L into 100 is given as 2%. Okay. Now put it over here and get the answer. So 4% plus 2 into 2 is 4%. So total error is going to be 8%. Done. Okay. What about this one? This is the last question from this one. What about this one? Yes, exactly. Guys, if the percentage error in the measurement of momentum and mass of an object is 2% and 3%, then the maximum percentage error in the kinetic energy is, guys, we say kinetic energy is 1 by 2 mv square. Multiply with m and divide with m. So kinetic energy will come out to be m square v square divided by 2m. What is m into v? That is momentum. So you will be writing kinetic energy over here, kinetic energy, and this is 2m is equal to, guys, 2m ke. This will be over here p square. We have to find the, okay, we have to calculate the energy, okay, in this one. So you will be writing it like this. So kinetic energy will be simply, that is p square divided by 2m. Okay, this is the final equation. So you have to find the error in the kinetic energy. So that is going to be delta k divided by k into 100 is equal to, so for momentum, 2 delta p divided by p plus, for mass, it is going to be delta m divided by m into 100. This is the final equation in this particular case. Now, I hope whatever the question can be asked in this particular case, you would be able to solve that particular question. That's great. That's great. Let's move on to this one. Extremely important. Extremely important. Extremely important. What is this? A ratio of displacements. Ratio of displacements. Take a look, guys. Take a look, guys. We say a ratio of displacements. If motion starts from rest, acceleration is constant. Let's suppose a car is starting from this point. A car is starting from this point. Initial velocity is 0 and acceleration is constant. These two conditions are supposed to be there. Okay. Okay. Now, guys, we say at time t is equal to 0. I'll make the car over here. Let's suppose this is the car over here. That is starting from this point. At t is equal to 0, initial velocity is 0. Acceleration of the car is constant. Okay. At t is equal to 0, car is here. Then car is moving. At t is equal to 1, car is here. At t is equal to 2, car is here. At t is equal to 3, car is here. At t is equal to 4, car is here. T is equal to 5, car is here, and so on. Now, if I say, guys, what is the displacement covered in the 1 second, in first second, you say, sir, that is x. Sir, how much is the displacement? If you say it is x, sir, how do you say it is x? It is like, you say, sir, s is equal to ut plus 1 by 2 at square. U, initial velocity is 0. 1 by 2, acceleration into t square. T is 1, because we have to find the displacement in 1 second. So that is 1. So it is going to be a divided by 2. Consider it x. What is the displacement covered in? We say 2 seconds. You will say, sir, s is equal to 1 by 2 acceleration into t square. 2 square is 4. Okay. So we'll be writing, this would be 4 into a by 2, because this is a by 2. 2 square. 2 square is 4. 4 into a by 2. What was a by 2? That is x. So this is going to be 4x. So displacement covered in 1 second is x. Displacement covered in 2 seconds is 4x. Similarly, by using the same formula, displacement covered in 3 seconds is 9x. Displacement covered in 4x is 16x. Then displacement covered in 5 seconds is 25x. Okay, and so on. Okay. Now, if somebody says, what is going to be the ratio of displacement in 1 second, 2 seconds, 3 seconds? So you'll be writing it like this. Guys. Displacement covered in 1 second is to displacement covered in 2 seconds is to displacement covered in 3 seconds is to displacement covered in 4 seconds is to displacement covered in 5 seconds. It is going to be x. Then we say is to 4x, is to we say 9x, is to 16x, is to we say 25x. This is going to be the ratio. Okay. So this is the displacement covered in 1 second, 2 seconds, 3 seconds. Yes. So where do we need to use it? Wait for some time. Okay. Then we have this one. Ratio of displacement in first second, second, third second, and fourth second. Guys, see. If I say the same car has started from this point. Okay. Initial velocity is 0. Acceleration is constant. It is traveling at t is equal to 1. It is here. At t is equal to 2, it is here. At t is equal to 3, it is here. At t is equal to 4, it is here. At t is equal to 5, it is here. Now, if the questioner comes and says, what is the displacement covered in 1 second? You'll say, sir, x already calculated. Displacement covered in 2 seconds, 4x. Sir, in 3 seconds, 9x. If I say, what is the displacement in first second? That is, sir, if this is x, this is x. Sir, what is the displacement in next second, second second? That is going to be 3x. Okay? Because if this is 4x, This is x. 4x minus x, that is going to be 3x. Displacement in third second, that is 5x. Displacement in fourth second, that is 7x. Displacement in fifth second, that is 9x. So basically, if this is x, this is 4x. So 4 minus x is 3x. If this is 9x, 9x minus 4x, that will be 5x. 16x minus 9x, that is going to be 7x. So this is the ratio of displacement in first second, second second, third second, fourth second, and fifth second. Now, let me just tell you this ratio. Guys, let me just tell you this ratio. So I would say ratio of displacement in first second is to displacement in second second is to displacement in third second is to displacement in fourth second is to displacement in fifth second. It is going to be x is to 3x is to, we say 5x is to, we say 7x is to, we say 9x. This is going to be the ratio. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats, everybody out there. Tell me, guys, is this clear with the fire emojis? Everyone means everyone. That's great. Now take a look at the question. All of these are previous year questions. All of these are previous year questions. Take a look. A particle experiences the constant acceleration. See constant acceleration. Okay. For first 20 seconds, starting from rest, initial velocity is 0, acceleration is constant. We can apply the condition. If it travels S1 for the first 10 seconds and distance S2 in the next 10 seconds. Okay. Guys. A particle travels for 20 seconds. Okay, this is 0 and this is 20 seconds. Okay, and it says for the first 10 seconds, okay, for the first 10 seconds, its displacement is S1. For the next 10 seconds, okay, its displacement is S2. Okay, then which of the following options is correct? Guys, which ratio you are supposed to use? I have to use in this, I would say this ratio. I would say this ratio. Ratio of displacement in first second, second second, third second, fourth second. Sir, can it be like this also? Displacement in first 10 seconds. First 10 seconds. First 10 seconds. Yes. It can be also displacement in second 10 seconds. Second, here it is displacement first 1 second. Then second 1 second. Third second, fourth second. So it can be displacement in second 10 seconds. Third 10 seconds. Okay. Or displacement in first 100 seconds is to displacement in second 100 seconds is to displacement in third 100 seconds is to. Ratio will be same. So I would say in this particular case, this S1 is to S2. It is going to be simply, that is x is to 3x. X is to 3x. Okay. Now I would say S1. Okay, we have to find the value of S2. So S1 divided by S2 is going to be x divided by 3x. X and x will cancel. So S2 will come out to be 3 times of S1. S2 is 3 times of S1. Okay, take a look at this. A body travels for 15 seconds starting from rest with constant acceleration. If it covers distance S1, S2 and S3 for first, see guys, a body travels for 15 seconds. This is 0 and this is 15 seconds. So first 5 seconds, it is traveling S1. Second 5 seconds, it is traveling S2. Third 5 seconds, it is traveling S3. Yes, this distance. You have to find, guys, which ratio I am supposed to use over here. Guys, again, I am supposed to use same ratio. That is S1, S first is to displacement in first second is to displacement in second is to, that is x is to 3x is to 5x is to so on. So I would say S1 because it says displacement for this interval, for this. It is not the complete distance. S1 is to, S2 is to, S3 I am supposed to use over here, that is x is to, 3x is to, we say 5x. You can write it like this. Okay, now we have to check which option is correct. Guys, first do one thing. Let's say S1 divided by S2. That is going to be x is to 3x. X divided by 3x. This and this will cancel. So S1 will be S2 divided by 3. If you take this S2, S2 divided by 3. Call this first. Then we can say, now guys, take a look over here. Now, if we do S1 by S3, S1 divided by S3, that is going to be x divided by, we say 5x. This and this will cancel. So S1 will come out to be S3 divided by 5. So this is equation second. Now S1 is equal to this. Okay, S1 is equal to this. S1 is also equal to this. So can I say from first and second, S1 is equal to S2 divided by 3, which is further equal to S3 divided by 5. Which option? Option C. Is this clear? Guys, you need to take care of this. What the question is saying. It is saying for first 5 seconds. First 5 seconds means this interval. Then next 5 seconds means this interval. Next 5 seconds. So you will have to ratio x is 3 is this. If it asks, let's suppose, what is the distance in first 5 seconds? Then what is the distance in first 10 seconds? Then what is the distance in first 15 seconds? Then it would be x is to 4x is to 9x. Then we can use that ratio. Complete distance. Take a look. A body starts from rest. What is the ratio of distance traveled by the body during 4th and 3rd second? S1 is to S2 is to S3 is to S4 is going to be x is to, we say 3x is to, we say 5x is to 7x. Okay, it is S4 by S3, S4 divided by S3. That is going to be 7x divided by 5x. This and this will cancel, 7 by 5. And this is also the previous year question. This is also the previous year. 7 by 5, guys. Okay, 4 is to 3rd. Yes, 7 by 5. First one, na? First option. Yes, A. Now, see this. This also was asked in Neet 2015. Sir, a stone falls under the gravity. It covers distance h1, h2, h3 in the first 5 seconds. Sir. If you release an object, guys, this is important. If you release an object, means initial velocity is 0 and its acceleration is g, which is constant, 10 meter per second. If you release an object, it falls. Okay, if you release an object, understand this. I'll give you the feel of this one. If you release an object from certain height, it falls. Okay, it falls. Now, guys, see, we say after t is equal to 1 second, it would be here. After t is equal to 2 seconds, it would be here. After t is equal to 3 seconds, it would be here. After t is equal to 4 seconds, it would be here. After t is equal to 5 seconds, it would be here. Something like this. Yes. And my dear Neet aspirants, in this particular case, always remember, if initial velocity is 0, acceleration is constant, means this would be x. This distance in the second 3x. In the 3rd second, it is going to be 5x. This is going to be 7x. This is going to be 9x. And distance in first second is x. Distance in 2 seconds is 4x. Distance in 3 seconds is, we say, 9x. Distance in 4 seconds is going to be 16x and so on. Same ratio we can use over here also. So in this case, option B is the correct option. It is exactly like this question. It is exactly like this question. It is exactly like this question. Okay. Same, exact same. Now tell me, is this clear? Is this clear to each and every single student? Tell me, guys. Is this clear? Now, guys, one more important thing, that is, see, we say if you have displacement position, this is velocity, this is acceleration. Guys, always remember these equations. These are the golden equations. If position is given, you have to find the velocity. You do differentiation, dx by dt, that is slope. Slope of position time graph gives you the velocity. If position is given, you have to find the velocity. You do dx by dt, differentiation of position. Okay. And if velocity is given, you have to find the position. You do the reverse. If displacement is integration of velocity v dt. Here you do differentiation, here you do integration. If velocity is given and you have to find acceleration, so you do what? Differentiation, dv by dt. So you do differentiation, dv by dt. dv by dt is slope. Okay, or v dv by dx. This is the acceleration in terms of displacement. Now, guys, if acceleration is given, you have to find the change in velocity. You do integration. Delta v is equal to integration of a dt. So from velocity, if you have to find, from position, you have to find velocity, you'd say dx by dt. From velocity to acceleration, dv by dt. Now, from velocity to position, integration of v dt, or area under velocity time graph, or from acceleration to velocity, integration of a dt, area under at graph. Simple. Okay. Now, guys, take a look at this question. The question says, a particle of unit mass undergoes one-dimensional motion such that its velocity v is equal to this. Velocity of the particle is given as beta x raised power minus 2n. This is the velocity of the particle, where beta and n are the constants and x is the position of the particle. Yes, so velocity is given in terms of position. The acceleration of a particle as a function of x will be, guys, acceleration has got two formulas. Always remember this one and this one. This is the acceleration in terms of time. This is the acceleration in terms of position. V dv by dx. So which one will you use over here? Here velocity is given in terms of position. So you will be using acceleration is v dv by dx. You will be using this formula, not dv by dt. So we say we have to find acceleration is velocity. Put this velocity as it is. So that is beta x raised power minus 2n. Okay, as it is. Then dv by dt. So differentiation of dv by dx of this, that is beta x raised power minus 2n. Done with the question. That's it. It looks difficult, but it is easy. So acceleration is going to be, that is beta x raised power minus 2n. Now, guys, take this beta out because it is constant out of differentiation. So beta out. How do you do the differentiation of x raised power minus 2n? If it was x square, we say power down, 2 down, x raised power 2 minus 1. So here, minus 2 will be down, minus 2n. Okay. Then we say x raised power minus 2n minus 1. Okay. Power minus 1. Now take it out. So beta into beta will be beta square minus 2n. Then we say beta square minus 2n. Then we say beta square. Then we say x raised power minus 2n. X raised power minus 2n minus 1. So it is x raised power minus 2n is minus 4n. Minus 4n. Then we say minus 1. This is going to be the answer. Minus 2n beta square. Minus 2n beta square. X raised power minus 2n beta square. X raised power minus 2n beta square. X raised power minus 4n minus 1. Option D. Option D. I hope this is clear. Simple. You have to use this formula and do the differentiation. Yes. Okay. What about this one? Guys, take a look. The initial velocity of a particle is u at t is equal to 0. The acceleration of the particle is given by, acceleration is given as alpha t raised power 3 by 2. Which of the following relations is valid? If there is a student out there who will be thinking, sir, I'll use v is equal to u plus a into t. V is equal, initial velocity is u. Acceleration, instead of acceleration, he'll be putting what? A raised power, a alpha, t raised power 3 divided by 2 into t. Okay. Okay. Now, that is going to be alpha t raised power 5 by 2. So, v is equal to u plus alpha t raised power 3 by 2 t raised power 1, that is t raised power 5 by 2. So if there is a student who is saying option 5, which is incorrect. Option 5 is incorrect. Why? Because here acceleration is variable. Acceleration depends upon time. Acceleration is not constant. So this equation is only valid when acceleration is constant. We say v is equal to u plus at. S is equal to ut plus 1 by 2 at square. V square minus u square is equal to as. All of these equations are valid when acceleration is constant. So here you cannot use this equation. Acceleration is this. Guys, see. What you are supposed to find out in this particular case? You have to find which of the relation is valid. Okay. Now do one thing. Can I say, sir, this acceleration, it is going to be dv divided by dt? Yes. It will be, sir, alpha t raised power 3 by 2. Yes. Now take this dt over here. So dv will come out to be alpha t raised power 3 by 2. And you say, sir, this would be dt. Now guys, integrate both sides. So initial velocity is u, final velocity is v. Time is 0 and this is t. So now here it is going to be v. Integration of dv is v from u to v. And here take this alpha out. Then integration of t raised power 3 by 2. It will be t raised power 3 by 2 plus 1 upon 3 by 2 plus 1, because power plus 1 upon power plus 1. Okay. Then I would say put the upper limit and put the lower limit. So v minus u, it will be alpha t raised power 3 by 2 plus 1. That is going to be 5 by 2 upon 5 by 2. So v is equal, take this u over here. This will be plus u because here it is minus, plus. Guys, take this 5 by 2 over here. This is going to be 2 by 5 alpha t raised power 5 by 2. This is going to be the velocity. So which option? Which option? Option C. Not option D. I hope you got the feel. Of this particular question. When acceleration is variable, at that point of time, what we can do? Okay. So, guys, when acceleration is variable, always remember, we say velocity dv by dx. This equation will help us. Acceleration dv by dt. This will help us. Okay. Or we can say also displacement is integration of v dt. This equation will also help. Okay. We say change in velocity will be integration of a dt. Okay. Or we say acceleration is v dv by dx. So all of these equations are valid when acceleration is constant, variable, whatever it may be. But v is equal to u plus at, s is equal to ut plus 1 by 2 at square, v square minus u square is equal to s. Those are only valid when acceleration is constant. Done with this? Okay, let's talk about this one. Guys, if you have a system something like this, I am asking you find the acceleration of the system, find the acceleration of the system and tension. Find the acceleration and the tension. Whenever you have a system something like this, always remember acceleration would be, we say net pulling force. Simple shortcut you remember, divided by net mass. You simply remember acceleration is going to be net pulling force divided by net mass. As simple as that. Acceleration is going to be net pulling force divided by net mass. Okay. Always remember acceleration is going to be net pulling force by net mass. Guys, see, this acceleration is net pulling force. Guys, this is a block over here. What is the force acting on this block in the downward direction? That is 50 Newton. What is the force acting on this block? This is 30 Newton. So these are considered to be the pulling forces. Sir, what about these tension? These are the internal forces. These are not the pulling. So net pulling force will be greater minus smaller. 50 minus 30. 50 minus 30. Sir, where does this 50 come from? If it is 5 kg, What is the force in the downward direction? mg, that is 5 into g. G is 10. 5 into 10, that is 50. So here 3 kg, 3 into g, that is 30. So 5 minus 30 divided by net mass. 5 plus 2 plus 3. You have to consider all three. 5 plus 3 is 8. 8 plus 2 is 10. So this is going to be 20 divided by 10. This and this will cancel. This is 2 meter per second. We got the acceleration 2 meter per second square. So this is the acceleration of this block as well as this block, because this is a connected block system. All will have the same acceleration. Now, I want you to understand one thing. If you, let's suppose, have to find the tension, this T2. Guys, see, how do we calculate tension? Consider this block, this 5 kg block. In the downward direction, it is 50 Newton. In the upward direction, this is T2 tension. This is the acceleration. Okay, this is the acceleration. Because obviously this force is greater, so acceleration is the same direction as net force. Use Newton's second law. What does Newton's second law mean? Net force is equal to mass into acceleration. First of all, when you have to find the acceleration, what will you do? Net pulling force divided by net mass. Then, if you have to find the tension, consider that block. What is the force in the upward direction? T2. What is the force downward? 50 Newton. Use net force is equal to mass into acceleration. Net force means this bigger force minus smaller force. Sir, why this one? Because direction of acceleration is downward. Obviously, this would be greater. So I would say this is 50 minus T2 is equal to mass into acceleration. Mass of this block is how much? That is 5. And acceleration came out to be 2. 5 into 2. Because acceleration of all the blocks is 2. So this is 50. 5 into 2 is 10. Take it over here. Minus 10. And take this over here. This is T2. 50 minus 10 is 40. So 40 Newton is the tension T2. Done. Sir, what about tension T? What about this T2, T2? Sir, can we find the tension T1? Yes. Consider this block. Okay, this is 3. In the downward direction, it is 30 Newton. In the upward direction, this is T1. Use Newton's second law. Guys, net force is equal to mass into acceleration. And this is the acceleration. So I would say that is T1 minus 30 is equal to mass into acceleration. That is 3 into 2, that is 6. So I would say in this particular case, T1 will come out to be 30 plus 6, that is going to be 36 Newton. As simple as that. Is this clear? Okay, what about this one? Simple. Find the tension and acceleration. First, find acceleration. Sir, in the downward direction, net force, we say pulling forces 30 Newton. Mass into acceleration due to gravity. Okay. And on this one, it is going to be 20 Newton. M into G. Sir, what is the acceleration? Net pulling force. Net pulling force is 30 minus 20. 30 minus 20. Net mass is 3 plus 2 is 5 kgs. So this is 10 divided by 5. This is 2 meter per second square. Done. Sir, what about tension? Find the tension. Take this block. Consider this block. Okay, this is 3 kg. In the downward direction, this is 30 Newton. This is going to be acceleration. In the upward direction, this is tension. Tension will be in the string. When there is a string, there is tension. Now apply second law. So net force is mass into acceleration. Net force is 30 minus T. 30 minus T is mass into acceleration. That is 30 into A. Acceleration is 2. So this is 30 minus 3 into 2 is 6 is going to be T. 30 minus 6, that is 24. 24 Newton will come out to be the tension in this case. Done. Yes. Sir, is there only one concept? Yes. Net pulling force divided by net mass. Is that clear? Is this clear, guys? Tell me in the chats quickly with the fire emojis. Okay. And smash the like button if you have not liked this session yet. And join this Telegram channel because notes, everything I share over here only. t.me/YAWARMANZOR. Everybody has to join this particular Telegram channel. Okay. Okay, what about this one? Guys, here. Find the tension T2 in the string. Let's first find acceleration. Guys, Acceleration in this case, net pulling force, net pulling force, net pulling force. How much is the pulling force over here? 40 Newton only. Sir, what about these tension? They are the internal forces. We do not consider those. Okay. So I would say net pulling force, that is 40. Net mass, 4 plus 6 is 10. 10 plus 10 is 20. This and this, 4 ones are 4 twos are 2 meter per second square. Done. Okay, we have to find tension T2. Consider this block 4 kg over here. Okay. And in the outward direction, this is 40 Newton. In the backward direction, this is T2 tension. Use net forces mass into acceleration. Use Newton's second law. Newton's second law is net force is equal to mass into acceleration. That is 40 minus T2. 40 minus T2 is going to be mass into acceleration. 4 into acceleration is 2. 4 into 2 is 6. So 40 minus 6 is going to be T2. So that is going to be 34 Newton will come out to be done, 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 done. Simple, simple technique. Okay, what about this one? You have this question over here. In the shown figure, in the system shown in the figure, all the surfaces are smooth string, okay? Find the acceleration of the system. Guys, how do we find the acceleration? Net pulling force upon net mass. So acceleration is going to be net pulling force. On this block in the downward direction, it is going to be m into g. So mg is, that is 100 Newton. M into g, 100 Newton in the downward direction. 10 into 10, 100. And here it is going to be tension T. Four into 2 is 8. Yes. 4 into 2 is 8. I thought it is 6. When did it change? So this is going to be tension. 40 minus 8, 32 Newton is the tension. Is that clear? Now guys, take a look. Acceleration is net pulling force upon net mass. This is 5 kgs, 5 kg mass. What is the net pulling force? That is 100 Newton, okay? Because tension is the internal force. Net mass, 10 plus 5 is 15, okay? 10 plus 5 is 15. This is 100 divided by 15, okay? So that is 5 3s are, 5 20s are. So that is going to be 20 by 3 meter per second square. This is the acceleration. Then tension in the string. Okay. Guys, consider that block. Consider this block. If you have to find the tension in the string, consider this block. This is 10 kg. In the downward direction, it is 100 Newton. And here it is tension T. And this is going to be the acceleration. Use net force is equal to mass into acceleration. 100 minus T. 100 minus T is equal to mass into acceleration. So that is going to be 10 into 20 by 3. Net force is equal to mass into acceleration. Mass is 10, acceleration is 20 by 3. So this would be 100 minus, take it over here. This is 10 and 20 is 200 by 3. Take it over here. This is going to be 200 by 3. And take this tension here, it is going to be T. So 300 minus 200, that is going to be 100 divided by 3 is going to be the tension. Okay, yes. Now you have to find the extension in the spring. Guys, here spring is connected. Always remember, if this is the tension acting on the spring, we say this spring will create the restoring force Fs. And that restoring force is equal to K times of X. So we say, the amount of tension, this external force you are applying, same amount of restoring force this is going to create. So I would say here, guys, here, this tension will be equals to the restoring force, that will be equals to the K times of X. Simple, simple. Make this equal. What is the value of tension? That is 100 divided by 3 is equal, because if you pull a spring, it will create the restoring force, K times of X. So I would say 100 by 3 is equal to K. Spring constant is 50. And this is X. This and this will cancel. Okay, so this was going to be 10 divided by 5 threes are 15 is going to be X. So 2 and 2 and this is 3. So X will come out to be 2 divided by 3. So this is the answer to third question, X. This is the answer to second question. This is the answer to first question. All the three cases we have done. Is this clear with the fire emojis? Is this clear with the fire emojis? Everybody out there. Okay. Let's talk about very important. Let's talk about this one. Very important. All the lovebirds in the chats, don't forget to like this session, okay? Because you guys have to mark the attendance. That's mandatory for you too. Okay. Now, guys, take a look. Center of mass. Guys, center of mass is that point where whole mass of the body is concentrated. Like if this is a pen, I'm asking you find the center of mass of this pen. It would be around the center only, where you can hold the entire mass of the pen. So this is going to be the center of mass. Okay, almost at the center only. So that point where the entire mass of the system can be assumed, you can say it like that also. Now, if this is a rod, if its mass is m, length is l, okay, this is a uniform rod. Mass is distributed uniformly, okay? Same amount of mass present here at every point. In this case, we say center of mass is going to be exactly at the center, that is L by 2. Simple, simple. Okay, center of mass is of this rod will be exactly at the center. Sir, how do you calculate? See, there is a formula. XCOM, center of mass, x coordinate of center of mass, because this lies on the x-axis only. That is going to be integration of x dm upon integration of dm. Guys, see, we say when it comes to the dm, understand this very carefully. We say lambda. Lambda is mass per unit length. How much mass is present on the unit length? If you consider a small unit length over here, we say its mass is dm and its width is dx. So this is going to be dm divided by dx. Okay. Mass per unit length. Unit length, this much of length has this much mass. So dm will come out to be, in this case, that is lambda dx. Okay. Now, if you got the value of dm, put it over here. So it is going to be integration of x. Instead of dm, we'll be writing lambda dx upon integration of dm. It is going to be lambda dx. Okay. Now, lambda is constant. Take the lambda out and integration is from 0 to L, 0 to L. Why? Because you have to consider all the elements of the rod. We are finding the center of mass of this rod. Ignore this, whatever I'm saying. Okay. So now, guys, it is going to be integration of x dx upon integration of lambda out, and this will be dx. Lambda cancel. 0 to L, 0 to L. Now, this is going to be x square divided by 2, and this is going to be x. Limits are from 0 to L. Limits are from 0 to L. Now, when you put the limits, it is going to be L square divided by 2. L square divided by 2 upon L square upon L. Okay, when you put the upper limit. This and this will cancel over here in this particular case. So I would say what is going to be the answer? That is L by 2. Whatever I said, Ignore this. Ignore this. Okay, just the derivation. If you have a rod, okay, and we say lambda is constant. Lambda is constant. Lambda means mass per unit length. The amount of mass present on this unit length is same on this unit length, is same on this unit length. It is constant. In that case, we say center of mass is present at L by 2 or 0.5 L. Simple, simple. Next, center of mass of variable mass system. If I say, sure, as you move towards this side, we say mass of the rod increases. Here, less mass is present on unit length. Here, more mass is present on unit length. Here, more mass is present on unit length. We say in this case, lambda is proportional to x. As you move along the x-axis, we say lambda increases. Mass per unit length increases. On unit length, mass increases. In this case, if they ask you to find out the center of mass, the long derivation method, integration method I have shown you, but directly remember here, if lambda is proportional to x, we say center of mass, this is the center, L by 2. Center of mass is going to be at x is equal to 0.6 L, 0.66 L. In the previous case, it was exactly at the center, 0.5 L. This will be at 0.6 L. Directly remember, very important. Next, if lambda is proportional to x square, okay, lambda is proportional to x square, mass per unit length is proportional to x square. In that case, center of mass will be at 0.75 L. Here it is L by 2. This is 0.75 L, where center of mass will be for this rod. If lambda is proportional to x cube, in that case, center of mass of that rod will be at 0.85 L. So somewhere around over here. I hope you got the crystal clear feel. You don't have to find its derivation. Like directly, if I take a look at the question, the density of a thin rod of length L varies with the distance x from one end as lambda is equal to, we say lambda naught x square by L. So can I say lambda is proportional to x square? Find the position of center of mass directly. Guys, when lambda is proportional to x square, position of center of mass will be at 0.75 L. Without solving the question, this is the answer. Is this crystalline clear? Guys, tell me in the chats. Is this crystalline clear? Okay, great. Take a look. Another chapter, important topics. Guys, types of collisions. Everybody knows there are three types of collisions. Elastic, first one. Let's take a look at the elastic collision. It is that collision after which the two objects regain its shape and size. Okay, guys. It is that collision after which the two objects regain its shape and size. Okay, it also regains its kinetic energy, which was converted to the potential during the collision. Like, guys, you have a mass m1 over here. It is moving with a velocity u1, m1, u1. You have mass m2 over here, which is moving with velocity v2. Now, this is before the collision. When the collision takes place, okay, so some deformation takes place over here because during the collision, okay, they are applying force on each other. After the collision, this is the scenario. This ball, m2 moves with velocity v2, m1 moves with velocity v1. Initially, velocity was u1, u2, finally it is v1, v2. So we say this type of collision in which two objects regain its shape and size and regains its kinetic energy. Whatever is kinetic energy finally, same as kinetic energy initially. This type of collision is called, we say, elastic. Which one? Elastic collision. Okay. And guys, we define a term over here that is coefficient of restitution, that is E. For elastic collision, coefficient of restitution is 1. What does that mean? Coefficient of restitution means velocity of separation, v2 minus v1. Okay, divided by velocity of approach. This one. With what velocity they are approaching, u1 and u2. This is called velocity of approach. With what velocity they are separating? This is called velocity of separation. Because after the collision, they separate. Before collision, they meet. Velocity of approach. Okay. So in case of elastic collision, we say E is equal to 1. So if E is equal to 1, this will be equal to this. Okay. Velocity of separation will be equal to velocity of approach. Okay. So for elastic collision, velocity of separation is velocity of approach. Okay. One more thing. Kinetic energy before the collision will be equal to the kinetic energy after the collision. Remember this. Okay. So kinetic energy remains conserved in case of elastic collision. Okay. Yes. Now, what about momentum? Momentum also is conserved. Guys, what is the momentum initially? Momentum of this mass into velocity m1 u1 plus mass into velocity m2 u2. What is the momentum finally? m1 v1, m2 v2. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now, very important thing, guys. Velocity initially is u1, velocity initially is u2. Final velocity is v1 and v2. If they ask you to find the velocity finally, v1 is m1 minus m2 into u1 upon m1 plus m2 plus 2 times of m2 into u2 upon m1 plus m2. You have to remember this. You have to remember this. Important. Or v2 is equal to m2 minus m1 into u2 upon m1 plus m2. Then we say plus 2 times of m1 u1 upon m1 plus m2. This is the velocity of the two objects in case of elastic collision after the collision. I hope this is crystal clear. Then we have inelastic collision. It is that collision in which two objects does not regain its kinetic energy. Guys, why did I teach you these topics? Extremely important. Okay, it is that collision in which two objects does not regain its kinetic energy. At the time of collision, deformation takes place, due to which kinetic is changing to potential energy. Guys, this object is moving with the velocity u1. This object is moving with the velocity u2. We say collision takes place. After the collision, see, the two objects are not fully recovered. These are the deformed objects. This is velocity v1, this is velocity v2. This is after the collision, this is before the collision. So after the deformation, masses does not regain its original shape and size in case of inelastic collision. Okay. And when it comes to E, E is basically coefficient of restitution, decides the elasticity. If E is less than 1, means body does not regain. If E is equal to 1, means body regains. That is elastic. So here, value of E is between 0 and 1. Okay. Now guys, in this particular case, in elastic collision, we say momentum remains conserved. Here, momentum also remains conserved. Okay. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay. Let's suppose if I say in an inelastic collision, coefficient of restitution is 0.5. So this will be 0. Coefficient of restitution is velocity of separation by velocity of approach. If this is 0.5, okay, 0.5 means 1 by 2. So multiply it over here. So it is v2 minus v1. Velocity of separation will be half of velocity of approach. So can I say in this case, if we say coefficient of restitution is less than 1, then velocity of separation will be half of velocity of approach, means velocity is decreasing. So velocity of separation is less than velocity of approach. Means if final velocity is decreasing, separation velocity is decreasing, final kinetic energy will be less than initial kinetic energy. Very important point. So kinetic energy is lost in compression or deformation. Kinetic energy is lost in compression and deformation. And in case of inelastic collision, we say momentum is conserved. Now, if somebody comes and he asks you, tell me, what is going to be the velocity of an object in case of inelastic collision after the collision? V1 is equal to m1 minus E times of m2 into u1 upon m1 plus m2 plus E plus 1 into m2 u2 upon m1 plus m2. Then v2, velocity of this object in case of inelastic collision after the collision, this v2. This is going to be, that is m2 minus e times of m1 into u2 upon m1 plus m2 plus e1 plus 1 m1 into u1 upon m1 plus m2. Yes, you have to remember these. Then we say perfectly inelastic collision. Okay, perfectly inelastic collision. See, it is that collision in which bodies stick to each other after the collision. Okay, some portion of the kinetic energy is recovered. Okay, now guys, see. This is the mass which is moving with m1 v1. This is the another mass m2 u2. Okay, so when they are basically, when they collide, after the collision, the two masses stick to each other and move with a common velocity. v1 is equal to v2 is equal to v. This is after the collision. This is before the collision. And here, coefficient of restitution is 0. That is the reason we say they are finally sticking together. No elasticity at all. Okay, so we say E is equal to 0. If E is equal to 0, so velocity this multiplied by this is going to be 0. So v2 minus v1 will be 0. So I can say v2 will be equal to v1, it will be equal to v. That's what I said. So kinetic energy is not conserved, momentum is conserved. Keep that thing in your mind. Okay. And guys, if I say finally the two objects move with the same velocity, in that case we say what is the value of that velocity? m1 u1, conserve the momentum. So initial momentum is m1 u1 plus m2 u2. Final momentum is two masses move together with a velocity v, m1 plus m2 into v. So this final velocity v is going to be m1 u1 plus m2 u2 upon m1 plus m2. This is going to be the final velocity. These are all the cases of, we say elastic collision, inelastic collision, perfectly inelastic collision. One more thing, loss in kinetic energy. In case of elastic collision, we say initial kinetic energy is equal to kinetic energy, loss will be 0. In case of inelastic collision, this is how do we find the loss. Very important. 1 by 2 m1 m2 upon m1 plus m2. Okay, this is u relative, 1 minus e square. What is u relative? That is u1 minus u2. Okay, u1 is the initial velocity of the mass m1, u2 is the initial velocity of mass m2. This is before the collision. Perfectly inelastic collision, loss in kinetic energy will be 1 by 2 m1 m2 upon m1 plus m2 into u relative ka square. This is going to be the loss over here. Now take a look at the question. Okay, see, this is the first question over here. Guys, this is the first question over here. Two masses m1 and m2. Two masses 4 kg and 8 kg. See, the diagram is this. This is 8 kg. It is moving with 4 kg and 8 kg. This is 4 kg. It is moving with 8 meter per second. Okay. And then you have this. This is 8 kg. It is moving with 4 meter per second. It is moving with 4 meter per second. Collide each other. Okay. And collision is perfectly inelastic. Collision is perfectly inelastic. Find the velocities of the mass after the collision. If the collision is perfectly inelastic, in case of perfectly inelastic collision, this is going to be the velocity. Yes. Now let me find the velocity finally. Guys, after the collision, if they are moving something like this, final velocity is m1 u1 plus m2 u2 upon m1 plus m2. Now tell me, v is going to be m1 m2. m1 is 4, m1 u1 is 8. Then we say minus. Why minus? Because this is moving in the opposite direction. So this is 4 into, we say this 8 divided by m1 plus m2. So 4 plus 8 plus 4. Guys, 8 into 4 is 32. 8 into 4 is 30. This and this will cancel. So it will be 0. So basically when they collide, they will come to rest. So that's why final velocity is coming out to be 0 in this particular case. Okay. Okay. What about this? A ball of mass m moving with a velocity v collides head on head with the second ball of mass m at rest. Okay. A ball of mass m. This is a ball m which is moving with a velocity v. Collides with another ball. Okay. So this is u1. u2 in this particular case is 0 because this is at rest. Okay. So after the collision takes place, if the coefficient of restitution is e, okay, and velocity of the first ball after the collision is v1, So this is the velocity of the first ball, it is v1. And velocity of the second ball after the collision is v2. This is the second ball, its velocity is v2. We have to find v1 and v2. Guys, consider it in inelastic collision. In case of inelastic collision, what is the formula for velocity? What is the formula for velocity in case of inelastic collision? Guys, that is m1 minus m2. See. I'll write here only. I'll solve that question here only. We say this is the velocity in case of inelastic collision. And you check over here, both the masses are same. This is mass m, this is mass m. This is also mass m. This is mass m. Its velocity is v, its velocity is u2 is 0. u1 is v and u2 is 0. So what I'll do over here is, we say u1 is v. I'll say this v1 will come out to be m1 minus m2. m1 is m minus e times of, coefficient of restitution is e times of, then we say this m, and this is given as v. Then m1 plus m2, that is 2m. And then this term would become 0. Why? Because this velocity, second ball is at rest, this would become 0. So this m will cancel. So v1 will come out to be 1 minus e into v divided by 2. Let's talk about this. Second, velocity of the second ball. Guys, this is the velocity of the first ball. So velocity of the second ball, that is going to be m2 minus e times of m1. This is m minus e times of m1. Okay, this is u2 over here. So this term would become 0. Why? Because second ball is at rest, u2 is 0, so this term would become 0. So v2 will come out to be, then it would be e plus 1, m1 into u1. m1 is m, u1 is v, initial velocity of the first ball, upon m1 plus m2. This is 2m. This and this will cancel. So v2 will come out to be e plus 1. Then we say v divided by 2. This is the velocity of the second ball. That is the velocity of the first ball. Guys, tell me in the chats, is this crystalline clear? Please tell me in the chats. Everybody out there, is this crystalline clear? Guys, smash the like button if you have not liked the session yet. Similar type of question, this I'm giving you as homework. Okay. Okay, take a look at this question. A ball of mass m moving with a velocity u suddenly breaks into two parts of ratio 2:3. A ball of mass m breaks into two parts, 2x:3x, because ratio is 2:3. If smaller mass comes to rest, this comes to rest, so v1 is 0. Okay, after the explosion, then the velocity of the second other mass will be v2. You have to calculate. Easy, bro. Okay, guys, see. A ball of mass m moving with a velocity v. This is moving with the velocity over here. Is v or u? It is u. It is u. Now take a look. Guys, can I say in this particular case, momentum remains conserved? Yes, in case of explosion, whatever it may be, momentum is conserved. Momentum initially, that is mass into velocity, m into u, is equal to momentum finally. Momentum of this would be 0. Why? Because this is at rest. So finally moment, I'll write it like this. M into u is equal to momentum of this. It is going to be mass, that is 2x into 0, plus mass into velocity, 3x into velocity is v2. Now guys, mass of this one, like here it is 2x, 3x. If you combine these two, it is going to be 5x. So this is going to be 5x into u. It is going to be is equal to 3x into v2. Okay. Now guys, this and this will cancel. So take this 3 over here. 5 divided by 3 of u is going to be v2. This is the answer. 5 by 3 of u. 5 by 3 of u. Okay, take a look at this. Guys. A ball of mass m falls from a height on the ground. If E be the coefficient of restitution, this is the ball, this is the ball, okay, this is the ball, okay, it falls on the ground from a height h. If E be the coefficient of restitution between the body and the ground, then the distance traveled by the body before it comes to rest. See guys, when the ball falls on the ground, covers height h, then it rebounds, okay, it will go till this height, then it falls again, then it again goes, rebounds, then it falls, okay. So before it comes to rest, okay, how much distance it has covered, how much total height it has covered. So that height would be this height h plus this is E square into h. Please remember this directly here. This would be this, then again E square into h. Then this would be e raised power 4 into h. This would be e raised power 4 into h. Now see, total height. This height plus this height plus this height plus this height plus this height. H plus 2 times of e raised power e square into h. This plus this is 2 times, 2 times, 2 times. This plus this is 2 times e raised power 4 into h, e raised power 6 into h, and so on. This becomes a GP series. When you solve this, this comes out to be the total height. H into 1 plus e square upon 1 minus e square, where e is the coefficient of restitution. H is the height from which it is falling. So you guys are supposed to remember this directly. They might ask this directly. Remember directly. If you release an object, it falls on the ground. How much height it will cover before it comes to rest? This much. Next part of the same question. A body of mass m falls from the height h on the ground. If E be the coefficient of restitution of the collision between the body and the ground, then the total time taken by the body before it comes to rest. Guys, how if it falls on the ground, how much time it is going to take in falling? Sir, this time is under root of 2h by g. This we study in motion under gravity. This is under root of 2h by g. Then this time while it goes up, plus this time while it comes down, plus this time while it goes up, plus this time, plus this time, plus this, and that we have to find the total time. Okay. Now, so first time will be under root of 2h by g. Second will be 2 times under root of 2 this h divided by g. It is simple, bro. It is simple. If I say while covering this height, how much is the time? Under root of 2h by g. That is under root of 2h divided by g. While covering this height, how much is going to be this time? This is going to be under root of, we said 2, this height, e square into h divided by g. And now this plus this is twice, so I would write twice. That's it. Similarly, what about this time? Under root of 2, this height, e raised power 4 into h divided by g, and this plus this is 2 times. So this plus this will be the total time. This plus this is going to be the total time. That is what is mentioned over here. This time plus this time plus this time and so on. This is also a GP. When you solve this, total time is going to be under root of 2h by g, 1 plus e upon 1 minus e. This is going to be the total time before the object comes to rest. Now, please tell me in the chats if this is clear or not. Remember this directly also. Remember this very important expression. Everybody out there. I need the signal from every single student with the fire emojis. Now see, this is the question which was asked in NEET 2013, 17, 19 and many more times. What does this? Gravitational potential energy of Earth mass system. See guys. You have Earth over here, its mass is capital M, radius is r. Okay, this is the radius. Now you go till height h, capital H, its mass is small m. If you place an object at height small m, at height h, okay? If you place an object at height h, what is going to be its potential energy? Guys, directly, please remember this. See. When an object is placed, on the surface, we write its potential energy as, if this object is placed on the surface, see, if this object is placed on the surface, we say its potential energy is going to be minus G mass of Earth, capital M, this M divided by R. When you take it to the height h, its potential energy is going to be minus G capital M small m divided by, what is the distance between the two? We say R plus H. Okay. Now, while taking from this to this, if I say find the change in potential energy, delta U, you'll say, sir, final potential energy minus this, this minus this. So when you solve that, so final answer is going to be this. This is the change in potential energy. If you take the object from the surface to height h, this is going to be the change in potential energy. That is mgh upon 1 plus h by r. H is the height. Now, if I say height is much less than radius of Earth, this height is very small. So now this height is very small, this radius is very large. Very small divided by very large, this term would almost become 0. Hey, yes. Now, if this is 0, 1 plus 0 is 1. This term would become 0. 1 plus 0 is 1. So we say potential energy would come out to be, that is mg into h. So that's why we say in our normal life, if you take an object, if you place it over here, how much will be the change in potential energy? mgh. In reality, this is the potential energy. This is the change in potential energy. 1 plus h by r. Now, if height is much less than radius of Earth is 6,400 kilometer. In that case, we say it is mgh. This expression was asked directly in NEET 2013, 17, 19. Now take a look at this question. An object is taken to the height h is equal to 2r. An object is taken to the height 2r, okay, above the surface of Earth. The increase in potential energy will be, what is the formula? Sir, delta A U is equal to mgh upon 1 plus h divided by r. You are taking the object to height h is equal to r. So we say potential energy is going to be mg, instead of h, it is 2r, divided by 1 plus h, instead of h, it is going to be 2r divided by r. This and this will cancel. 2 plus 1 is 3. So it is going to be 2 mgr divided by 3. So that is 2 by 3. We say mg into r. This is going to be the potential energy. Change in potential energy. Yes, 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 yes. Okay, this one. Guys, take a look at this. Gravitational potential due to a hollow sphere. Okay, see guys, if this is a sphere over here, its radius is r. If I ask you how much its mass is capital M, if I say how much is the potential due to this sphere at small r distance, which is outside, guys, at outside point, potential due to this would be minus gm by small r. This is the potential due to this sphere at outside point. Okay, yes. And on the surface, guys, we say when you move towards the surface, on the surface, value of small r will be equals to the capital R. We say put, instead of small r, you put capital R over here. So it is going to be minus gm divided by capital R. This is the potential on the surface. Okay. And guys, when I say potential inside, inside we say potential will be same whatever is on the surface. So minus gm by capital R. So from inside to surface, potential in case of hollow sphere is constant. That's why it is minus gm by small r, minus gm by small r. Okay. Now, if somebody asks you graph, very important graph. Very important. So graph, guys, this is center. At center, we say value of small r is 0. Okay. We say from center to surface, potential is constant, minus gm by r. See, g is universal gravitational constant, m is mass of Earth, r is radius of Earth, if you consider this as Earth. Radius of sphere is constant, mass of sphere is constant, g is constant. So we say from center to surface, it is constant, inside. Okay, this would be where r is equal to capital R, surface. And outside, it is v is inversely proportional to r, so rectangular hyperbola. But sir, since if you check over here, we say potential is negative, negative, negative. So the actual graph would be something like this. Is the graph of mod of V. So the actual graph would be something like this. It would be from the lower side, from the lower side, from the lower side. Okay. Now, the same concept we study in the electrostatics. The same concept we study in the electrostatics. Guys, if you have a sphere, hollow sphere, okay, radius of this is capital R, charge on this is Q. What is the potential at outside point? What is the outside point at potential? What is the potential at outside point due to the sphere? You say V outside is, that is, guys, here in this case, it is minus gm by r. G is the universal gravitational constant, m is mass, r is the point where you have to find. Here, instead of g, we say k, Coulomb's constant. Instead of mass, you have over here charge divided by at what distance, that is r. When it comes to the surface, V surface is going to be kq divided by capital R. Here it is gm by capital R. When it comes to inside would be kq divided by capital R. Okay. Now, if you make the graph over here, that is potential versus R. This is electric potential. In gravitation, we study gravitational potential. If from surface to inside, it is going to be constant. V is constant inside. And in outwards, when you say outside, it is inversely proportional. V is inversely proportional to small r. That's why rectangular hyperbola. Very important. And this has been asked many times in the Neet. Many times. Now, gravitational potential due to solid sphere. Hollow sphere means football. Solid sphere means cricket ball, in which mass is present inside also. This is a solid sphere. Its radius is capital R. So you have to find the potential outside. Guys, outside formula is going to be same. Outside formula is going to be same. Minus gm by capital R. Small r, small r. And when we say surface, on the surface, value of small r is capital R. So we say instead of small r, it will be capital R. When I say inside, guys, inside. Sir, inside at what point? Inside at this r distance. Here inside, it will not be same as surface, but it would be different. What is that? Minus gm divided by 2r cube. R is the radius. Then 3r square minus small r square. Small r is the distance inside. See, for inside point, small r is less than capital R. For outside point, small r is greater than capital R. Now, guys, if I say exactly at the center, how much is the potential? When we talk about the center, we say this would become 0. This small r. Because at center, small r is 0. When this term would become 0, so it would become this r square and this cube will cancel. 3 by 2 gm by r. That's minus 3 by 2 gm by r. And guys, take a look. Take a look. This is at the center. I can write it like this. VO is equal to minus 3 by 2 means 1.5 gm divided by r. And this is the surface. This is the surface. Now tell me where the potential is. If we say magnitude, where the magnitude of potential is large, this is 1 times gm by r. This is 1.5 times gm by r. So if we make the graph, guys, we say, when we say magnitude of potential on the surface, that is gm divided by r. Magnitude of potential, we say at the center, that is 1.5 times gm by r. So 1.5 is greater than 1. So at the center, here, this is center where r is 0. At the center, potential is going to be large. Then it will decrease. When we talk about the surface, we say potential is gm by r. At the center, it is 1.5 times. Then we say outside. Outside, it is inversely proportional to r. Because when you say V out, it is gm divided by small r. Since this potential, and this potential all are negative, so the actual graph would be something like this. This is V and this is R. So exact graph from the lower side. Exact graph from the lower side. Okay, now take a look. I'll show you. Guys, Electric potential in case of solid sphere. If you have a solid sphere in which charge is present inside also. Okay, how much Q? Radius is R. If I say what is the potential at outside point in case of solid sphere, okay, you say, sir, V is KQ divided by small r. Outside it is same. If I say what is on the surface, sir, KQ divided by capital R, because on the surface is outside. On the surface, value of small r is capital R. When I say inside, guys, it is exactly like this. It is exactly like this. Here it is Gm by 2r cube. Over there it will be Kq divided by 2r cube. 3r square minus small r square. Kq divided by 3r cube. Okay. Okay. Kq divided by 2r cube. That is 2r cube. Then we say 3r square minus small r square. This is the potential inside. Inside means you take at any point inside at small r distance. Okay. Okay. And when we talk about center, guys, at center, we say at center value of small r is 0. If you keep small r as 0, so this would become kq upon 2r cube, and then we say 3r square. 3r square. This r square and cube will cancel. So this will become 3 by 2 kq divided by r. And if somebody asks you to plot the graph, at the center potential is large, 3 by 2, 1.5 times. Okay. So and on the surface it will be small. So on the surface, from the center to surface, and it would be something like this. This is Vs, this is Vo. So this would be R is equal to R. This is outside, where V is inversely proportional to small r. I hope this is clear. And the difference between electric potential and gravitational potential, here it is positive. But when we talk about the gravitational potential, this is negative. Its value is negative, negative, negative. Okay. Guys, tell me in the chats, is this crystalline clear to each and every single student? Is this crystalline clear? I need to know in the chats. Is this crystalline clear? Everybody out there. Is this crystalline clear? Is this crystalline clear? With the fire emojis. All of the topics that I have told you over here, along with the graphs, extremely important. Okay. So this is the electric potential, in case of solid sphere. Okay. So guys, that's all for today. See you guys in the next session. Okay. That will come very soon. That's all for today. I hope you like the session. And I would want you guys to, when I end the session, I would want you guys to let me know in the chats how was the session. I would want you guys to let me know in the not in the chats, in the comments. Do comment down below how was the session when I end the session. Okay. So that's all for today. Thank you. Okay. And do join my Telegram channel. That is here. This is the Telegram channel. Okay. That is t.me/Yawar Manzoor. YAWRMANZOOR. Okay. Because all the updates, everything will be over there only. Okay. So guys, take care and bye-bye. I'll be sharing the notes in the Telegram channel only. Take care and bye-bye. Thank you so much.